Okay, good day everyone. So we're here for another topic for your hydraulics and that would be the orifice. So kung nagtataka kayo kung hindi na tayo there is no sunod on sa laboratory number 1 ninyo, it is because no we are needed no to discuss this topic before tayo mag-proceed sa inyong laboratory number 2. Okay, kasi hindi nyo malalaman or hindi nyo mabivisualize yung mga formulas na gagamitin natin sa laboratory if hindi pa natin na-discuss itong topic na to at sa mga sumunod pa na topic. Okay? So sige, so let us start. So let us define what is orifice is all about. So by definition, no, orifice daw is any opening having a closed perimeter made in a wall or partition used for measuring flow of fluids. So note that when the area of the tank is more than 16 times the area of the orifice, let us neglect the velocity of water inside the tank. Ibig sabihin, kapag napakalaki daw, 16 times daw yung bigger yung area ng tank natin kasi sa orifice natin, is ina-neglect natin yung velocity because baka nga napakalaking storage of water na yung kino-consider natin, like yung mga dams and reservoir natin. Diba sinabi ko last time that ang reservoir natin is nine-neglect na natin yung velocity niya. No, kasi parang hindi na rin natin nalalaman yung speed of water or speed of the fluid in the reservoirs natin. So again, ang orifice daw, it is made by closed perimeter. So it is attached minsan sa side of the walls of the tank or minsan nasa ilalim rin siya mismo ng tangke natin. So ang orifice is ginagamit to measure the rate of flow of our fluids. So sa pag sinabi nating orifice, meron tayong dalawang kino-consider sa pag-solve yan. That would be your orifice with constant head and that would be the orifice with falling head. Okay, so you have flow under atmospheric pressure for constant head. You have submerged orifice and you will have head loss in the orifice. So pag falling head, aalamin natin dito kung ilang oras, no, ilang oras ba mauubos yung laman ng tangke. Okay, so wala akong picture ng orifice. So sige na lang, ito na lang, drawing na lang natin. So yung orifice no is parang siyang bilog lang na ganyan. Bilog na ganyan, ito yung magiging ito yung magiging yung parang siyang donut style, no? Yung tubig natin is lalabas dito sa gitna. Okay, dyan yung magiging labasan ng tubig natin. So usually daw, ang orifice daw, if it is our tank, ang orifice daw is being attached sa walls ng ating tangke. Dito lalabas yung tubig. Yan lang yung magiging outlet ng tubig. Or ang orifice din daw is pwede nating ilagay dito sa ilalim ng tangke natin and pwede rin siyang dito lumabas yung fluid natin. Okay, so take note that nakadepende rin sa rate of flow ng ating fluid ang magiging diameter ng ating orifice. Kasi yung orifice natin comes with different diameters. Okay, pwedeng malaki, pwede maliit. Kung sa atin pa, ang orifice, tinutulungan niya no, yung tubig natin to maging stable yung pag-discharge niya. Kasi imagine na lang sa hose, 'di ba kapag ang tubig is or sa gripo na lang, yung gripo na lang kapag bumubuhos yung gripo, parang scattered yung magiging discharge ng tubig, 'di ba? But then again, once na nilagyan mo siya ng hose, okay, nilagyan mo siya ng hose, 'di ba? Parang nagiging stable yung flow of water niya. Parang ganun din yung magiging idea ng orifice natin. Sinistable niya rin yung pag-discharge ng tubig natin galing sa tanks. Okay? So pag sinabi natin orifice with constant head, ibig sabihin yung height of water inside the tank at a given time, it will still remain the same. Like for example, ito agad yung magiging tank natin. Tapos meron tayong orifice na nag-discharge ng tubig within our water level. Ito yung magiging H natin, your head. No, your head is considered as galing sa water surface ninyo papunta sa center of your orifice. Kasi doon naman lalabas yung tubig natin. So by the given time, no, as time goes by, yung magiging H natin is constant, hindi nagbabago yung height ng ating fluid inside our tank. Okay? So pag sinabi naman nating falling head, so you have here sabihin natin nandito nag-discharge yung tubig natin. So you have here your water level. This is considered as your H1. So parang dito as the time goes by, kung meron daw tayong time as given, ilang tubig na lang yung magiging H sub 2 natin. Ibig sabihin yung tubig natin inside the tank is nababawasan ng nababawasan. Hindi constant yung magiging storage ng tubig inside of our tank. Yun yung pinagkaiba nilang dalawa due to time. Okay? So dito muna tayo sa orifice with constant head. So you have your flow under atmospheric pressure, you have submerged orifice, and you have your head loss of orifice. So if it is your surface water, okay, it is your head. No? Tapos dito lumalabas yung tubig natin kasi dito naka-attach yung ating orifice. Okay, so since it is a continuity principle, no, what comes in comes out, gagamit pa rin tayo ng Bernoulli equation natin. So you have your V squared over 2G plus P over gamma plus C is equals to V squared over 2G plus P over gamma plus C. So same sa sinabi ko kanina, if this is our point 1, and dito sa orifice natin ang point 2, sa point 1, ang magiging velocity niya is equal to 0. Okay? Considering that it is a large storage of water. So, nina-neglect na natin yung speed ng ating tubig. So, P over gamma, it is also being neglected because ang pressure natin, since it is an open, no, yung pressure natin is equal to 0 also. So, Z, that would be the distance coming from point 1 papunta sa point 2. Okay? So, for point 2, there is velocity to be considered kasi meron tayong flow or speed of tubig na lumalabas mismo sa ating orifice. Tama? Pressure is considered as 0 since it is open in the air. So for Z, that would be point 2 papunta sa point 2, that would be equal to 0 also. It's because ang point 2 mismo yung nagiging datum natin. Okay? So leaving us, di ba yung Z, that would be equal to H also, that would be the elevation. So H is equal to V squared over 2G. So manipulating our equation, no, we can conclude that your theoretical velocity is equal to V sub 2 is equal to square root of 2GH. No, nilipat na natin yung 2G dito and then square root. So you have, we can calculate your actual velocity given by you have your V is equal to CV times your V sub 2, where your V sub 2 is square root of 2GH. Ano ba yung CV? That would be the coefficient of velocity. Okay, it is the ratio of the velocity of your water jet of vena contracta to theoretical velocity. Ano ba yung vena contracta? Okay, dito mamaya natin yung pag-uusapan kung ano yung vena contracta. Sige nga na lang. Pag-uusapan natin kung ano yung magiging vena contracta natin. Okay? Yung vena contracta natin, ito yung the narrowest flow ng tubig na nanggagaling sa jet or sa downstream natin. Okay? Ito yung magiging area ng tubig na nabuo nang galing sa orifice. So, di ba meron tayong diameter dito ng orifice? We are considering an area here, big letter A, since your big letter A is considered as the area of your orifice. Okay? So since ito lang yung magiging outlet lang ng tubig natin, dito lang pwedeng lumabas yung tubig, no? It is in a form of a diameter or a circular. Yung tubig na na-form mismo ng pag-discharge ng tubig na galing sa ating orifice. Okay? Yan yung tinatawag na jet, yung pagbulga ng tubig natin dito. At meron tayong kino-consider na area ng shape ng ating vena contracta. And that is called as your small letter A. That would be the area of jet of vena contracta. Again, ang vena contracta, ito yung narrowest flow ng tubig na galing sa jet or sa ating downstream. Yung downstream is yung pag-flow ng ating tubig. So again, ang vena contracta is ang area ng tubig na nabuo galing sa orifice. Tama naman talaga, di ba? Ito yung area, ito yung tubig, no, na nabuo na nanggaling sa orifice kasi nga yung orifice lang yung magiging outlet ng tubig natin. Okay? So for number 2, let us consider submerged orifice. So ibig sabihin, wala naman masyadong pinagbago ang idea nito sa number 1 natin. Ang pinagkaiba niya lang is that there are two tanks that is being attached to each other. So ibig sabihin, if this is our flow 1, nandito yung magiging flow 2 natin, yung tubig natin is naglilipat dito sa compartment B. Parang compartment A, compartment B. So this is considered as This is considered as your H1 and this is considered as your H2 kasi magkaibang tangke sila. So the same formula, no, for your theoretical, or I mean for your theoretical velocity, that would be square root of 2g. But then again, that would be the difference between the elevation of the water level of the two tanks. So that would be H1, H sub 1 minus H sub 2. Okay, so you have a formula here for your discharge, no? So you have Q is equal to CA square root of 2GH. Ano ba yung magiging C natin? That would be the coefficient of your discharge. Ano ba yung coefficient of discharge? Ito yung characteristics, no, ng flow natin at ng pressure loss natin, ng behavior ng ating orifice sa ating fluids. Parang yan pa rin yung mga coefficient natin sa mga friction natin. Kung napapansin nyo, kung dati meron tayong friction factor, we have your head loss, you have your manning, a roughness coefficient, and you have your C. Parang ganun yung nagiging idea natin dito. So you have a note there, if there is a pressure on the top of the liquid surface, convert it into equivalent height of the liquid that is presented in the container. So kung meron na tayong present na pressure daw sa ating tank, so hindi natin siya pwedeng isosolve kung hindi natin siya i-convert, no? Hindi natin siya i-convert as a height or as one liquid lamang. So for number 3, you have here consider as your head loss in the orifice. So that is in the formula V squared over 2G times 1 minus over CV squared minus 1. So formula na ito, medyo familiar kayo. Tama? It is the formula or it is the head loss of your nozzle. Tama ba? Nagamit na natin yan last time. So makes sense kasi, 'di ba? Kasi yung ating nozzle at ang ating orifice, parang the same lang yung idea nila kung paano sila gamitin. Okay? It comes with diameter also yung nozzle. The orifice also is in diameter. So you can also use the formula HL is equals to H times 1 minus, I think that would be 1 minus CV squared. Okay? Paki-correct yan. This one should be 1 minus CV squared. Okay? So, ano pa bang kailangan kong yan dito? You have here your CC. You have your CC is equals to area of your jet of your vena contracta divided by the area of your orifice. That would be the coefficient of contraction. Bakit tayo may tinatawag na coefficient of contraction? Take note, no? For example, in this tank, napakalaking tank nito. Okay? At ang outlet niya lang is yung magiging orifice lang natin. So, ibig sabihin, track ng orifice natin yung tubig natin para mag-form or para doon lang siya lumabas. Isipin nyo ha, rectangular shape yung magiging tank natin tapos lalabas siya sa orifice natin as a circular. Ibig sabihin, kinokontract nga yung tubig natin, kinokontract nga yung tubig ninyo to discharge as what is the diameter given. Okay? Parang kinokontract natin yung tubig natin. Okay? So you can solve also for your coefficient of discharge as C is equal to CC times CV. Okay, so para mas maintindihan natin, let us try some of the examples. So you have here a 75 mm diameter orifice discharges as 0.023 cubic meters per second of a liquid under a head of 2.90 meters. So the diameter of the jet of the vena contracta is found by calibrating to be 66.25 mm. So let us try to find the discharge, the coefficient of contraction, and the coefficient of velocity. So let us try to draw that one. So sabi niya meron daw tayong tangke. And then you have an orifice na meron tayong 75 mm diameter. Okay, ano pa? Tapos meron tayong diameter ng jet natin or ng ating vena contracta as 66.25 mm. And you have a head which is the water level natin galing sa taas papunta sa center of your orifice. And that is considered as 2.90. Okay, so for letter A, hahanapin natin yung ating coefficient of discharge. So your C that can be solved by your CC times CV. Ang problema natin sa formula na ito is that hindi natin alam yung CC, hindi rin natin alam yung CV. But you can always use the formula of your discharge which is Q is equal to CA times square root of 2GH. So by this, alam natin yung magiging discharge. That would be 0.023 is equal to your C times the area of your orifice. That would be pi over 4 times 0.075 squared times square root of 2G times your H is 2.90. Your G is that would be 9.81. Ha? So therefore your C is equal to 0.69. Kindly pause na lang no and check if the value is correct. Okay, inom na tayo. Okay, so for letter B, let us try to find your coefficient of contraction. So ang formula natin for coefficient of contraction, as I said a while ago, that it is the area of your jet of your vena contracta divided by the area of your orifice. Therefore, you will have pi over 4 times 0.06625 squared divided by pi over 4 times 0.075 squared. So how much is the value of your CC? Makipos na lang and kindly confirm if the value is 0.78. So for letter C, let us try to find your CV. Yung CV natin is nakikita sa ating theoretical velocity. That would be actual velocity. That would be CV square root of 2GH. So ang problema natin dito, wala tayong velocity. So wag na natin pahirapan yung sarili natin, di ba? Wag na tayong maghanapan ng velocity kasi alam naman natin na pwede yung ma-solve ang coefficient of velocity ninyo through the formula of C is equal to CC times CV. So C is 0.69, your CC is 0.78, and we will find the value of your CV. So the value of your CV, that would be 0.88. Kindly confirm na lang if the value is correct. Okay? So I hope naintindihan no, kung ano yung nangyayari. Kinuha pa lang natin yung mga coefficients natin. So let us jump to another example. So you have here another one. So sabi dito, you have a 75 mm diameter orifice under a head of 4.88. So drawing natin. So ito, ay na, next. So yan. So meron na tayong orifice attached dito. So the head is 4.88. So under discharge of 8,900 Newton in 32.6 seconds. So meron tayong trajectory which is 4.76 and a drop of 1.22. So ibig sabihin na a drop of 1.22, ibig sabihin yung tubig natin is nasa or nakapatong sa mataas na lagayan. Okay, so isipin na lang natin na tangke ito ng tubig natin. Okay, ito yung magiging itsura niya. Basta imagine nyo na lang. So ibig sabihin yung y distance daw natin, no, galing sa ating tangke papunta sa ground, that would be considered as 1.22. At yung x natin, yan yung magiging distance ng jet natin or yung pagbuga mismo ng tubig natin. Okay, kasi trajectory yan eh. No, so that would be the x distance galing sa orifice papunta sa tip ng ating jet, okay? Your x is considered as 4.76. So for number 1, let us try to find the coefficient of velocity daw. And your CV can be seen sa V is equal to CV times square root of 2G H. Okay? So, anong problema natin ngayon? Pwede din natin gamitin nga yung C is equal to CC times CV. Ang problema natin ngayon dito, wala tayong CC, wala tayong CV. So, imposible na magamit natin yan. So, in this case, gagamitin natin itong formula natin sa velocity, which is CV is equal to CV square root of 2GH. Okay, so anong gagawin natin dito? Okay, let us have here for your x. So alam naman natin that your velocity, okay, your velocity formula, that is distance over time. Okay, so ano yung given sa atin? We have your distance which is your d is equals to x. Yan yung magiging distance ng jet ninyo coming from your orifice papunta sa tip. So ibig sabihin, x is equals to velocity times your time. Okay? So, ang problema natin dito, meron kayong X, tama, pero meron kayong X. Meron kayong X, pero wala kayong velocity at saka time. Saan ba natin nakukuha yung time natin? Take note, you have given a trajectory Y. At yung Y natin, pwede natin makita sa falling head ninyo. Di ba? Yung may nahuhulog. So, that would be Y is equals to 1/2 GT squared. Sana naalala yan sa dynamics ninyo. Okay? So, pwede natin makuha na yung mga values na yan. So, take note that you have your trajectory y is equals to 1/2 gt squared. Where your y is 1.22, 1/2. Ang g natin, that would be your gravity, 9.81 times your t squared. So, ilan kaya yung magiging value ng time natin? Solve ko rin. That is 0.498. Kindly confirm ha, that would be 0.499 seconds. Therefore, pwede na nating makuha yung velocity natin. So let us try to have your x is equals to vt, where your x is 4.76, yung velocity natin, times yung time na na-solve natin, which is 0.499. Therefore, your velocity, that would be equal to that would be equal to 9.539 meters per second. Okay? So therefore, pwede na natin makuha yung CV ninyo. That would be 9.539 is equals to CV times square root of 2 times 9.81 times yung height natin na 4.88. Kindly confirm sa mga values, guys, ha? I'm not certain sa values talaga. Sige nga, kindly solve. So I guess our CV, that would be 0.975. So pag i-confirm na lang yan. Okay? So let us go to your number 2. Sabi sa number 2, let us try to find the head loss of your orifice. Your head loss formula, that would be V squared over 2G times 1 over CV squared minus 1. Okay? So ilan yung magiging head loss natin? Okay? Your head loss is equals to oh, let us try the other formula na lang para mas madali tayong matapos. No, yung shortest formula natin. The other formula. Okay, so let us try the other one formula that would come to HL is equals to H times 1 minus CV squared. It is the simplified formula. Okay, so you will have 4.88 times 1 minus 0.975 squared. So therefore, your head loss, that would be equal to 0.241 meters. Pag i-confirm na lang. Okay? So let us proceed for your number 3. Sabi niya dito, power loss in watts. Okay, and you all know that your power formula, that would be P is equals to Q gamma E. So yung energy dissipated natin is also equals to your head loss, not to be considered. So ano yung magiging value ng Q natin? So take note, you have given there a discharge of 8,900 Newton of water in 32.6 seconds. Ibig sabihin, your Q, that would be 8,900 Newton divided by 32.6. So let us convert that one into cubic meters per second. So let us divide by 9,810 Newton per cubic meter. Yeah. So therefore, ilan ang magiging value nito? 8,900 divided by 32.6 times 9.81. Therefore, the value of your Q, that would be 0.028 cubic meters per second. Therefore, your power loss is equals to 0.028 times your gamma, which is 9,810 times your head loss or your energy dissipated, that was 0.241. Okay? Therefore, your power, that would be equal to 65 watts. Kindly confirm na lang. Okay? And that is your final answer. So let us go through the last example for your tawag niya ito, orifice with constant head. So sabi dito, you have two compartments, A and B, are connected by an orifice having a diameter of 140 mm at its sides. So compartment A, it contains water at a depth of 3 meters above the orifice and a pressure at the top of it equal to 50 kPa. On the other hand of the compartment, it contains water at a depth of 2 meters above the orifice pressure of the top. So C is equals to 0.86 and your CV would be equal to 0.92. So let us try to find your discharge, your head loss, and your power loss. So try muna natin i-draw kung ano yung ibig sabihin ng ating problem. Okay, so meron kayong compartment A and compartment B. So these two tanks are closed and being held with a pressure inside. For compartment A, you have 50 kPa, and for compartment B, you have 15 kPa, and the diameter of your orifice, that would be 140 mm. So according kanina, no, kung natandaan nyo doon sa principle natin, sabi doon na note daw, if may pressure daw inside the tank, no, i-convert daw natin yung pressure na yun into a height na para maging isang as one sila ng liquid. And you all know that the formula for your pressure, that would be P gamma H. Okay, that would be the unit weight density times the H. So when it is in terms to your height, i-convert natin sa height yan. Therefore, your H, that would be equal to P divided by your gamma. Okay, so ibig sabihin, itong water inside the compartment A na 3 meters in height, no, is madadagdagan siya ng height kasi i-convert nga natin yung pressure into a water or into a liquid. Therefore, yung H1 natin, that would be considered as 3 plus P over gamma. Okay, so take note, so that would be 3 plus 50 divided by 9.81. Therefore, your H1 is considered as 8.097. Paki-confirm yan ha. So how about for your H2? Since meron din siyang pressure, i-convert natin yung pressure into a height. Okay, so you will have 2 plus 15 divided by your 9.81. So ilan yan? That will be 4.568 meters. So for letter 1, for number 1, okay, I think the value is wrong for H2. Sige nga, pag-confirm kung mali nga talaga. I think the value for H2, that would be 3.529 No? That would be 3.529. Okay, so for your discharge formula, you will have Q is equals to CA square root of 2GH, where your H, that would be the difference between the height 1 minus your height 2. Okay, so Q is equals to 0.86 times the area of your orifice, pi over 4 times 14 squared multiplied by 2G, your G is 9.81, so you have 8.097 minus 3.529. Therefore, the value of your discharge is 0.125 cubic meters per second. So, kung hindi pa kayo natapos ng solve, i-pause nyo lang muna ha. Okay. That is for number 1. So for number 2, let us try to find the head loss of the orifice. So you have a formula HL is equals to H times 1 minus CV squared. Where your H, that would be the difference between your H1 and H2. Sulat ko na lang na ganyan. 1 minus your CV, that would be 0.92 squared. Therefore, your head loss, that would be 0.702 meters. Okay. For number 3, the power loss in watts. So you have your power formula. P is equals to Q gamma E. So you have your Q as 0.125, 9,810 times your energy dissipated, which is 0.702. Therefore, your power is 861 watts. Kindly confirm lang sa value ha. Please try to calculate that. Okay, so we are down sa inyong falling head, no? So yun yung sinasabi ko, yung falling head ninyo is nanggaling, yung falling head ninyo is sinosolve natin yung time, no, ng pagtanggal ng tubig or pag-change ng height ng tubig inside of your tank at a given time. So you have here your T is equal to 2AS squared of H1 minus square root of H2 divided by your CA square root of 2G, where your AS is your cross-sectional area of your water inside your tank. So, saan ba nanggaling yung ating falling head na formula? No, dinerive lang yan through integral calculus. So, you have your time, that would be yung lower limit times higher limit natin, ay lower limit at higher limit, that would be your H sub 1 and H sub 2. Kasi di ba magdi-differ dito yung time na ating makukuha. So that is your area of your tank divided by CA times square root of 2GH DH. In terms of DH tayo din dito kasi nga yung height yung kukunan natin with respect of time. Okay? So because of our height of the fluid inside the tank is nagbabago due time. Tama? So, try natin itong i-manipulate itong formula ito. Bakit tayo nagkaroon ng ganyan? So, you will have T is equal to higher limit, lower limit, AS. Di ba? The square root of H siya. So, pag tinaas natin yan siya, that is considered as negative 1/2. Tama? So, this is considered as CA square root of 2G DH. Okay? So, pag dinistribute natin yung tinatry na natin siyang i-distribute through your integral calculus. So you will have a formula of 2, ay medyo mataas. So integral calculus, okay? So that would be x raised to n plus 1 divided by your n plus 1. So meron tayong naiwan dito na, sana yun? So negative 1/2 plus 1, that would be positive 1/2. So you have positive 1/2, H is equal to positive 1/2 divided by 1/2. So yung 2 itaas natin, that is why meron kayo nakikitang 2 dito. No? Itataas lang natin siya. So you will have 2AS positive of H 1/2 divided by CA square root of 2G times your lower limit and upper limit, that is H1 and H2. That is why you have a formula of 2AS square root of H1 minus square root of H2 divided by your CA square root of 2G. Now, nasolve lang siya using your integral calculus. Okay? So for number 2, you have your time for the water to be in the same level. So same lang siya ng idea, di ba, ng yung compartment A and compartment B. But then again, dito, hinahanap natin yung time daw na yung compartment A and compartment B is the same level of water na sila. So you have your A and your B here as the cross-sectional area of your tanks. Your AB, that would be the area of your orifice. Okay, your H1, that would be your initial height. Your H2, that would be your final height. So let us have a problem here para mas maintindihan natin. So here, you have a small orifice, sabi yung area of 0.003. So, nakalagay daw siya sa vertical side ng ating tank. And the cross-sectional area of the tank is 0.40 meters squared. And the head is 1.2. And 312 seconds, no, naging 0.6 na lang daw yung tubig. So let us determine the coefficient of discharge, and C is equals to 0.60. How long will it take for the surface to 1.2 to 0.8? So sige, itry natin yang isolve. So for letter A, sabi niya, let us determine the coefficient of your discharge. So you have a formula for your time is equals to 2AS is equals to square root of H1 minus square root of H2 divided by CA square root of 2G. Therefore, yung C, yung hinahanap natin. So, sa loob daw ng 312 seconds, no, yung initial height natin is 1.2. Pagkatapos ng 312 seconds, yung H2 natin or yung tubig inside the tank natin is naging 0.6 siya. Therefore, your time, that would be 312 2 times area of your tank, which is 0.40, times your square root of 1.2 minus square root of 0.6 divided by C times the area of an orifice, which is 0.03 times square root of 2G. Therefore, the value of your C, that would be 0.62. Pause nyo lang, tapos confirm nyo yung value natin. Okay? So, for letter B, let us try to find daw, no? Ano yung hahanapin natin? yung time yung hahanapin natin. If your C daw is given as 0.60, your H1 is 1.2, and your H2 is 0.8. Sige nga, pakisolve the same formula. No? Ito yung magiging formula natin for your time. Sige, so for your time, that would be 201. Nabak siya. That would be 201.70 seconds. So, sige, pause nyo lang and kindly confirm. So, 1.2 to 0.8. From 1.2 to 0.8, you have 201.70 seconds. So, let us try to have this one. So you have here a tank in cross-sectional section 10 meter high. It takes 8.4 minutes to empty it through a hole at the bottom when the tank is full of water at the start. So hanapin daw natin yung pag-trap ng tubig by 3 meters. How long will it take to drop to 10 meters to 4 meters, and see the diameter of the hole given that your C is equal to 0.60 and the diameter of the tank is 2.4. Okay. Sige. Let us have here. So, sige, let us try to solve that one. No? So, having the given na nakikita ninyo for this problem, have you noticed no, na wala tayong given ng area ng tank, wala tayong given ng area ng ating ng orifice natin. That is why doon papasok no, yung ating na-solve kanina or yung ating formulas that I derived. Okay, so you have your T is equals to your AS times your H raised to negative 1/2 divided by CA square root of 2G. Ang problema natin is wala nga tayong area for your tank and area for your area for orifice. Okay? That is why gagawa tayo ng bagong variable ninyo. So, ito, let us try na i-change yung ating ink color. Okay? So, ibig sabihin itong formula na ito is gagawin nating variable K natin. Okay? Meron pa tayo dito, nakalimutan ko yung higher limit and lower limit. So, gagawin natin yan siya as a variable K natin para ma-solve natin siya without having the area of your tank and your orifice. So, ibig sabihin, yung magiging equation natin, that would be T times K times square root of H1 minus square root of your H2. So, according sa problem, ang tank daw natin is punong-puno, no? Tank is very full at the very start. Okay? Tapos, may-empty siya or mauubos yung tubig natin at 8.4 minutes. Okay? Therefore, pwede natin makuha ang value natin ng K natin. Paano? So, that would be, ang time natin, that would be 8.4 minutes times 60 para ma-convert natin siya into seconds times K times square root of H1. Ay, yung magiging H1 nyo. Okay, take note that the tank is full. The cross-section height of the tank is 10 meters. Ibig sabihin, yung ating water surface papunta sa ating orifice, that is considered as 10 meters. Ano yung maging H2 natin? Di ba at 8.4 minutes, mauubos yung ating tubig inside the tanke. Therefore, yung H2 natin is considered as 0. Sana naintindihan yan. Okay? Therefore, the value of your K, that would be 79.69. Okay? So, puntahan natin yung question letter A natin. So, how long will it take for the water level to drop the upper by 3 meters? Okay? So, take note, ano yung magiging H1 natin? That would be equal to 10 meters. Ano yung magiging H2 natin? That is equal to 3 meters. So, do you agree na yung H1 natin is 10 meters and H2 natin is 3 meters? Do you agree? So, by that, pwede na natin kunin yung time, no? Paano nung kunin yung time? That would be T is equals to, mali yung formula natin. Meron pa tayong 2 dapat dito dapat. Do you have 2 there? Kaya pala iba yung value na nakukuha nyo siguro. So, you have 2K square root of H1 minus square root of H2 ninyo. Okay, yung 2 natin is galing sa original formula natin na T is equals to 2AS square root of H divided by CA square root of 2G. Diyan yun siya nanggaling. So, ano kaya? Yung maging H1 natin, H1 is correct, your H2 is wrong. That is not considered as 3 meters. So, take note tayo sa grammar natin. It is considered by 7 meters. Sabi niya, ang tubig nyo daw is bumababa ng 3 meters. Take note, by ang ginamit niya. Magkaiba ang to sa by. Okay? Pag by daw, ibig sabihin, mababawasan ng 3 meters yung original height ninyo. Okay? If your original height is 10 meters, bababa siya ng 3 meters. Therefore, yung natirang tubig is in 7 meters. Tingnan nyo tong sa letter B. Sabi nga ang drop ng tubig is 10 meters to 4 meters. Ibig sabihin, from 10, bumaba siya ng 4. For your letter A, by 10 meters, bababa siya ng 3 meters. That is why your H2 or your H sub 2 is 7 meters. Okay? So, try to solve that one. You have 2 times 79.69 is equals to your H1, which is 10. Your H2 is equals to 7. Therefore, the time to be considered is 82.32 seconds. Okay? Kindly confirm the answer na lang. So, for letter B, your H1, that is considered as 10 meters. For H2, that is considered as 4 meters. Kindly get the value of your time. Same formula, same procedure. And your T, that is equals to 185.24 seconds. Okay. So for letter C, hanapin natin yung diameter ng ating orifice, which is small letter D. So saan ba natin nakikita yung areas natin? Di ba lahat ng area natin is nakapasok sa ating variable K? Therefore, you have your K is equals to the area of our tank divided by your C times area of your orifice divided multiplied by 2G. And you all know that the value of your K, that would be 79.69. Area of our tank, given that you have a diameter of 2.4. So you have your pi over 4 times 2.4 squared divided by yung C natin, which is 0.60 times pi over 4 d squared square root of 2g. Therefore, the diameter of your orifice is considered as 17.8 mm. Paki-compute ha and kindly confirm the values. Okay, so you have here another example. So sabi dito, you have compartments A and B communicating by an orifice having an area of 0.3 meter squared. So C is equals to 0.60. Meron tayong area for A, meron tayong area for B. So hanapin natin yung discharge from A to B. So sabi dito, you have a compartment daw. You have two tanks that is being attached to each other. Okay, dito lumalabas. Tapos yung height ng ating compartment A, it is, hindi sinabi sa problem. Sige, drawing ko na lang. It is having a height of 6 meters and yung compartment B natin, it is 3 meters. Therefore, your H or your head, to be considered, that would be H is equal to 6 minus 3. Therefore, our H to be considered is 3 meters. So, for letter A, let us try to find the discharge from A to B. That would be Q is equal to CA square root of 2GH. So, you have 0.60 times pi over 4 times, sana yun? Oh, meron pa tayong area ng orifice. Okay, times the area given. You have an area given as 0.3. So you have 0.3 square root of 2 times 9.81 times our H, which is 3. Therefore, the value of your discharge is how much? That is 1.381. 1.381 cubic meters per second. Okay, so for letter B, find the time that the water tanks will be on the same level. So, ibig sabihin ng same level, yung tubig natin is magkapareha na sila ng height, papunta from the water surface, papunta sa ating orifice. So, take note that you have your formula, that is 2AB square root of H divided by your area of the tank plus area of the compartment B times C times area of the tank square root of 2G. Okay, find the time that they are on the same elevation. So you will have 2 times your A, which is 10 times 40 for your B, square root of 3 divided by 10 plus 40. Madali lang talaga, formula based lang tayo. Times 0.3 square root of 2G. Therefore, the time that we are needed para pantay yung tubig from point A to point B is, solve natin. So I compute the value as 20.854. 20.855 seconds. So kindly confirm the values for our problem, for our answers rather. So the last example for this topic. So drawing ko muna. Let me draw. Bahala na, ano ha? Medyo tikwi. Hindi siya medyo tikwi gid siya. So, sige. So, you have here a problem na meron doon tayong tank comes with different fluids inside. Bakit natin nalaman na meron tayong different fluids inside? It is because meron tayong nakikita tatlong specific gravity, no? That would be 0.8 for oil, 0.9 for gas, and 0.105 for your sea water. Okay? So according to the law of our law talaga, according to the principle of our hydraulics is that hindi natin pwedeng isolve or hindi natin pwedeng ma-compute yung values natin inside our tank if meron tayong different fluids inside. So ano yung kailangan natin gawin? No, i-consider natin lahat ng fluids inside as one. Ibig sabihin, pwede natin i-consider na lahat na nandito na fluids sa loob is seawater or pwede na magiging gas lahat or pwede magiging oil lahat. No? Ibig sabihin, if i-consider natin lahat as seawater, yung gas at saka oil niyo is i-convert niyo to a seawater. Okay? Kasi hindi naman ninyo pwedeng ma-compute yung H natin, no? Bilang matic na as 0.6 plus 0.4 plus 0.8. Hindi natin yun siya ganun i-consider. Kasi i-consider rin natin yung fluid inside our tangke. 'Di ba? Ang C, yung hinahanap natin, that would be Q is equal to CA square root of 2GH. Baka yung H ninyo na i-base is that would be 0.6 plus 0.4 plus 0.8. That is wrong. Okay, i-consider rin natin yung oils, I mean yung fluid inside our tanks. Okay, so yung H natin that can be solved by i-convert nga natin lahat-lahat into, ano ba? Into seawater. Okay? So, ibig sabihin, you will have 0.80. That would be the height of your seawater. Lagyan natin dito, seawater. Okay? Plus, yung height ng ating gas, which is 0.4, multiply by the specific gravity. Tapos, paano natin siya i-convert into seawater? I-divide lang natin yung specific gravity niya. This one is gas. So, in this case, no, kino-convert na natin yung gas into a seawater. Plus, i-convert natin yung oil. That would be 0.6 times 0.8 divided by 1.05. Ito yung para sa oil. Therefore, your total height, considering that yung fluid natin inside would be a seawater alone. So, sige, compute natin sabay-sabay kasi hindi ko rin na-compute ang value nito. That would be equal to 1.6. I hope same tayo ng nakukuha. Therefore, the complete height of the fluid inside the tank or our head is considered as 1.6. Okay, it is considered as seawater. Kinonvert natin siya into a seawater. So let us try to solve for number 1. So you have Q is equal to CA square root of 2GH. Okay, wala pala tayong value ng Q. Sige, bigyan na lang ako ng value ng Q natin, no? Hindi ko na-copy yung sa problem. Given that yung Q na lang ulit is 0.023 cubic meters per second. So you will have 0.023 is equals to C times pi over 4. Ano yung magiging area ng ating diameter given that diameter is 1.2. So you have 1.2 squared times square root of 2 times 9.81 times yung H na na-solve natin, which is 1.6. Therefore, the value of RC is how much? That is considered as napakaliit, no? That is 3.63 times 10 raised to negative 3. Sige lang kasi napakaliit rin ng ating kinonsider na discharge. So that is the correct answer for letter C. I hope the same tayo ng answer na nakuha. So for number 2, time to remove the sea water. Okay, time to remove the sea water. So take note that yung H1 na kinonsider natin, that would be equal to 1.6. Okay? For our H2 to be considered is yung 0.8. Bakit 0.8? Kasi yan lang naman yung height ng original na seawater natin inside our tank. Okay? So, pag sinabing seawater, hindi natin masasabi na lahat-lahat na ito i-flow na natin, no? Matatapon na siya. Hindi. Okay? Ito yung kinonvert natin na height considering that all the fluid is as one, but your H2 that is considered as the original height of the fluids inside. Okay? So, you have your T is equals to, ano nga yung formula natin? That would be 2AS square root of H1 minus square root of H2 divided by CA square root of 2G. Okay? So, your H1 that would be 1.6 and your H2 that would be 0.8. Sige, baki-solve ng ating time. Maliit masyado yung ating C, no? Sige, okay lang. Kasi maliit din naman yung discharge na ginamit natin. Oh, how about the area of the orifice? Hindi ko rin nakuha yung area of the orifice. Sige na lang. Let us have the area of your orifice as 0. Ano nga yung kanina sa problem natin? That is 0.3 meters squared. Sige lang, at least yung principal yung ating nakukuha dito. Okay lang yung values natin. That would be 579.1 seconds. Okay. So, ibig sabihin, yung oras na matanggal yung seawater natin inside our tank will take 579.1 seconds. So, for number 3, number 3, yung time na ma-remove naman yung seawater at yung gas natin. Okay? So, ganito na lang yung isipin natin. Okay? I-add na lang natin yung time na ma-remove yung gas at yung time ng sea water natin. Okay? Okay lang ba yun? Kasi ito na 579.1 seconds. So, considering na lang na ang naiwan na lang sa tank, okay? Na naiwan na lang na tubig or na fluid sa tank would be gas and oil. Okay? So, therefore, you will have 0.6 as your oil and you have 0.4 as your gas. So, therefore, i-convert naman natin ngayon, no, yung mga fluids natin lahat as one, which is yung gas natin. Kasi yung tubig daw natin, hindi ko pala na-mention kanina, no, yung mga fluids natin is mag-flow galing sa ilalim. So, therefore, you have your new height, which is H is equals to 0.4, yung gas natin. Tapos, yung oil, i-convert natin into a gas. Paano nga yun? That would be height of your oil plus a specific gravity of your oil divided by your specific gravity of your gas. Okay, para mo-convert siya, that would be 0.9. Therefore, yung H natin to be considered, that will be 0.4 plus 0.6 times 0.8 divided by 0.9. That is 0.93. I have a wrong pala. This is considered, yung H2 natin that is considered as 1.6 minus the original height, no, ng ating substance na itatanggal sa tank, that would be 0.8. Kaya meron kayong 0.8 also. Okay, sige, sorry for that one. Na-confuse rin ako. Again, yung H2 natin, that would be the difference between the converted liquid minus the original height of the liquid. Okay, so dito, in this case, this is considered as your H1. How about yung H2 natin? Yung H2, hindi siya magiging 0.4. Okay, can you take note of that? Hindi siya magiging 0.1. Mali yung first na sinabi ko na yung H2 ninyo would be the original height of the water. No, that is, of the liquid. That is wrong. That should be the difference between the converted height of the liquid minus the original height of the liquid. So in this case, you have 0.93 minus the original height of the liquid, which is 0.4. Ganyan pala dapat. Sorry about that. 0.4. Therefore, your H2 would be considered as 0.53. Okay, sana naintindihan. Again, yung H2 ninyo, it is a difference between the converted height of all of the liquids minus the original height of the fluid. Okay? So, sige, paki-compute ang ating time. Same given, no, yung height lang ang nagbago. Sana all nagbabago. So you have 1.2 squared times square root yung H1 natin, that would be 0.93. Your H2, that would be 0.53. Times your C, 3.63 times 10 raised to negative 3. Yung area ninyo ng orifice, that would be 0.3. Square root of 2 times 9.81. Therefore, the time to remove the gas inside our tank, that would be 110.832 seconds. So, ang tanong ko ngayon, is this our final answer for number 3? The answer is no. Tama. Bakit magiging no? Kasi itong 110.832 seconds is yan lang yung time no, ng paglabas ng gas sa tangke natin mismo. What is being asked is that the time ng seawater at ng gas. Therefore, your final time for number 3, that would be time for seawater plus time for your gas. Therefore, you have 579 ba yan? 579.1 plus 1110.832. Therefore, the total time ng paglabas ng seawater at gas natin sa ating tangke, that is considered as 600, di na siya sumusulat. 600, ayaw nyo na talaga magsulat. 600, ayaw nyo na magsulat guys. 600, oh, bakit ayaw nyo na magsulat? Paki-take note na lang nun, ayaw nyo nang sumulat, that is considered as 689.932. Okay, so our discussion is done for this afternoon, or I mean for this day. No, so kung na-receive nyo ito ng late, sorry for that, no, kasi ang dami natin is inaasikaso rin. So siguro sa pagbalik ng klase natin, no, once we are go back sa ating klase natin, I will discuss another topic about orifice. I think ang topic na natin sa sunod is all about the open channels, no, para makaproceed na tayo sa mga laboratories natin. Okay, kasi yung sunod ay it will talk about the open channel laboratories natin. So, i-discuss ko muna yon para tuloy-tuloy na yung laboratory works ninyo. And take note that your laboratory output, no, please keep that one kasi after that, i-compile natin yan lahat. So, if you have any concern and clarification about this topic, kindly PM me or sa GC na lang para isahang sagot. So thank you everyone and God bless.